Hello, welcome everyone. My name is Przemysław Szepecki and I'm recording in Stockholm, Sweden. I used to travel by train to my office in northern Stockholm. That gave me quite, you can see I have a long way to go. That gave me quite a lot of opportunities to practice the coding dojo. But now, even in Stockholm, the winter is gone, so I changed the train to a bicycle. Bicycle is a bit slower than the train. And I cannot practice the coding dojo while I'm riding, so I didn't practice that much in recent weeks, so I hope you excuse me if I make a bit more mistakes this time. This week we will try to implement the Roman number converter. The Roman numbers is the numeric system used by ancient Romans. You can see that they didn't use the, let's say, numbers, they used some letters and symbols to code the value of the number, and the basic idea is that the symbols add to each other, and if they are written in reverse, then can subtract. Can read all about the Roman numbers in the Wikipedia. And now we'll start our dojo. So I start by opening the test file, and as usual we include the Google Test Framework files. Our implementation will be in roman.h, and we can write a very simple first test case. So just check first one of the symbols. So to start with, we will try to convert the numbers to symbols. So I just choose the number of 1, and that should be the capital I symbol. Okay, we need to make some implementation, put a class for Roman number in this template, and we write the constructor. Our constructor should take the integer value, and we need to return a kind of string, or at least we need to compare our Roman number with the string. So for that one it will be very useful to actually inherit the string implementation. So I subclassed a standard string, and now we can just use the append function to add some letters to the Roman number string. Let's see if that works. The test case is passing, so that's good. We managed to implement the first test case. Now let's try for all the other symbols that we have, at least some of them. So I, V, X, L, and D should correspond to 1, 5, 10, 50, and 100. Okay, and then we need to do some more implementation, as we need to choose the symbol based on the value that seems like mapping one to another. Let's use a map for that. So I just start by adding the value to the map. 1, 5, 10, 50, 100. We need 2, 3 more. It will be the 500 and 1000. Make them in line. Okay, now the V, X, L, C, D for 400 and M for 1000. Okay. Now I just need to declare the map object. So we are mapping the integer values to string values, and we have called that symbols. That should work, hopefully. Just the header file for the map. And we should check if it really works. Yeah, we of course need to choose the correct symbols. And now something's wrong for the D. Of course, here in the test case it should be capital C. Yeah, one symbol. We are ready with conversion of the one symbol. So let's try right now adding some symbols together. So now if we are going to convert the value of 2, that should be the double I. So we need to add the I for 1 and another I to get 2. The test case is failing, so our current implementation doesn't deal with adding the symbols. But hopefully it should be not that difficult to implement. So we have the value I, and we need to choose the symbols, the biggest symbol value from our map, add it to our string, and subtract it from the initial value. So let's find the biggest value, not smaller than or smaller or equal to our given number. For that I will use the upper bound. The upper bound will return the iterator to the map, and to avoid writing the long iterator, I use the auto type. It's a very convenient feature. So upper bound will return the value which is at least or bigger than the I. So then I need to go one back, so id minus minus, and we append the symbol to our string and subtract the value, the numeral value from the I. Let's see if that works. I think I swapped the first and second. So the first is the number which we need to subtract from the I, and the second is the symbol. Now it's compiling. Symbols that we append to our string. Let's see if it works also for other values like 3, and let's try something more complicated. So MC LX VI, complex numbers would correspond to 1166. Yeah, hope I calculated correctly. Yeah, it's working fine. And now we need the Romans not only added the symbols together, they can also subtract some numbers. So if we have I before V, that will give us 4. Let's see how that test case will go now. It's failing. Our implementation now tries to add 4 times I together, so I, and we should replace it with the IV. The simplest way to fix it is just to add more symbols to our implementation. So without much complexity in the logic, we just add the more symbols to our table. So I write the symbol for 4, 40, 90, 400 and 900. So we add more data and keep our logic quite simple. And that will be 900, and that should be CM. Yeah, the test case pass. That was quite obvious that we just have the 4 directly in our symbol table. Let's see if some more complex Roman numbers will also work. It's 999. How the Romans will write it? It's should be CM for 900. then XC for 90 and IX for 9. Well, 19 should be XIX, and let's check one more value. Say 1049, that should be like M, and then XL for 40 and IX for 9. We are failing the test case. This 999 is not working. We got it as VAL IV. So instead of 9 written as IX, we got V IV. The problem is maybe we forgot. We have some error in our symbol table. The number here looks correct. Let's check the symbol table. Here we have 4, 5. There are swapped. It doesn't matter. But we are missing the symbol for 9. Actually, we should add that also. We try to add all the, let's say, 2-letter symbols that correspond to all, let's say, 4s and 9s. So we should add a symbol for 9 also. So just IX should be the value of 9. Okay. Now let's see if everything will pass. Yes. Great. That's fixed all the implementation. Of course, we should check the binary values. Assert that the exception is wrong when we have the value which cannot be converted to a Roman number. So there's Romans has no number for a 0. They didn't have any negative values, and they cannot write down the 4000 value or even any of the bigger values. So that would be the good check for the all the out of range values. And right now we are not casting an exception, so let's check if I is less or equal to 0 or I is more or equal than 4000. We just throw a standard out of range exception, and let's add the text that Romans could not count from 1 to could count from 1 to 3,999 only. Yes. Okay, and we need a new header file for the standard exceptions. So inc std except, and that should be fine. The exceptions are thrown as we expected. And the last thing, we could, let's say, iterate through all the supported range just to check well, that we didn't get the empty string or we didn't get an runtime error for it. So let's assert false, that the string we get from Roman number for any supported number is well, not empty. So Roman empty should be false, and just call that assert for all the range of the numbers, so from 1 to 4000, and we should hold. And yeah, so it would be a good test case. Just need the type for the eye here, and now it should pass. Yes. Have the 100% coverage, so we have all the test cases pass. And I think that should be all for today. Next week we'll try to make the conversion the other way around. So, see you next week then. Hey!